Hi everybody, it's Martin from Branco Customs here, and in this video I'm going to show you how I built this awesome hatchet. I did in fact create a full 3D CAD model of this and dimensional drawings. However, as I haven't got a printer that's quite big enough to print out this ginormous hatchet, I had to adapt, improvise and overcome. In fact, I scaled it to size on my laptop screen and traced it onto 2 pieces of paper. Shabam! For this project I ordered in a nice big piece of 6.2mm thick by 150mm wide D2 tool steel. I smeared blue dye chem over it like there was no tomorrow, and then set about with my scissors, like Blue Peter, trimming out the template of the axe. I laid the template on the top and then scribed around the edges, leaving nice permanent marks in the blue die chem. I use the die chem because when it gets hot from the angle grinder, it doesn't just disappear, whereas if you use something like a Sharpie marker, as soon as it gets a bit of heat to it or a bit of water on it, then when on stainless steel and things like that, it just disappears. So die chem is number 1. I then move over to the angle grinder and start chopping out that profile. The angle grinder is only really good at making straight cuts, so I roughly trim around it and then later go back onto the main grinding machine in order to prettify it up and take the grind lines straight up to the edges. Perhaps in a future video I'll turn some of the waste material into another kind of knife. It's a very laborious task as angle grinding. You have to, especially to get into tight compound corners, you have to make 1,000 tiny little cuts and then go back over them to cut them all out, which it's a pain, but it's a lot better than using the belt grinder, which is a lot slower, and the abrasives are probably 10 times the price of an angle grinding disc. So we only really use that for finishing up. As you can see, the small wheel attachment fits perfectly into a lot of the different finger grooves. Funnily enough, that was fairly intentional. A lot of my designs revolve around the equipment that I've got. If you can use a radius tool to make the radius that you need, it ends up coming perfect every time. So now the profile's been ground to its finished size, I get my vernier calipers out and I scribe a center line from both sides. This gives me a good idea of where the true center will be with this finished geometry as to where I've ground it. I then use that line to go along and put the holes in the centers. I then fix it into the milling machine in order to start making slots. For this I used a 10mm tungsten carbide milling cutter, and very slowly, about 1mm depth per pass, just chopped it out bit by bit. I then went back over to my small wheel attachment to make these awesome choils at the front and back of where the handle meets the blade. I think they look pretty sweet. It was then back onto the milling machine to use the ball nose cutter to put fullers into the blade. I chose to put 3 of varying lengths, getting shorter towards the top, and line them up perfectly from one side to the next. The idea with these is that when I come and grind the primary bevel, they'll end up sort of starting very thin and small and widening out as the thickness of the blade increases. These fullers should also actually help the performance of the axe, so when you, for example, whack it into a nice tight log, it should help create air release so that you don't end up with a vacuum and too much stickiness going on. So it should help you break the axe back out of what you've put it into, be it a car door or something like that. I then used my main knife grinder in order to start putting the primary bevel on the main cutting edge of the axe. After that, I flip it around and I use my platen set at 45 degrees with the table in order to put a nice sharp point on the back edge. More of a piercing point than a cutting point. I then put the same 45-degree angle chamfer onto the bottom of the pry bar. Then back onto the milling machine to go around and put some knife chamfers on all the holes. I then scribed the shape of the handles onto a very large piece of black micarta and then take it to the bandsaw to chop them out. Two things are happening here. Both, micarta is a tough material to cut, and secondly, I need a new blade for my bandsaw. I clamp the rough cut handle scale onto the axe and then take it over to the drill press, where I carefully go through every single hole in turn so that all the holes will line up with the holes in the tang when it's done. I then take it over to the router. Now again, this is a case of don't try this at home, because really I should have a full router table with safety guards, which you can see I don't have. So I then use the router in order to flush cut or trim cut all of the handle material extruded profile of the axe, and then later on I go over that with a nice radius cutter in order to make it nice and round. It then goes back over to the milling machine so I can mill some nice radius grooves into the handle. These will add a little bit of extra interest, and secondly some extra grip. Then for a little bit of weight reduction and a bit of added interest, I put some varying sized holes in a nice line and then put nice big chamfers on them, which I think look pretty sweet. So now the blade's all ready, nice and shiny and ready to go heat treated. So I get out the stainless foil and wrap it up and then pop it in the kiln. D2 steel, it gets ramped up to 1020 degrees C, then is quenched between aluminium plates with forced air to cool it rapidly, and that hardens the steel. Believe it or not, the thicker the item that you're heat treating, the more likely chances there that it's going to warp. And luckily for this one, it came out perfectly straight, which was great. After a quick cleanup, I then added my logo onto the top of the blade. So then, in order to add a little bit more interest, I decided I'd do a acid etch splatter pattern. So for this, I carefully covered over my logo with nail varnish because I didn't want that to be etched, and then used the nail varnish to splatter in a random pattern everything else. And then basically the bare bits, when I dip it into some acid, will turn a darker grey colour. Then when I come back and wipe off the nail varnish, those bits will still be nice and shiny underneath. I then turn my attention to the finishing details of the micarta. This is a bit of a bear to get a nice finish on, so I ended up having to sand it up to very high grits of around 1200, and then take it over to the buffing wheel in order to polish it. I'd created some counterboard recesses in each location where there was going to be a screw, and found these really nice anodized aluminium little washer cups, which will take a countersunk screw head perfectly. Then in each of the holes in the tang of the axe, I've positioned some nice interference fit brass threaded knurls. Now these are going to be what I can then screw the handle scales into. Both the tang of the axe and the inside of the handle scales were then epoxied with G-Flex epoxy, and then everything was assembled. Even the screws, all the lanyard dowels, everything was epoxied together to make one monolithical unit. You never know what sort of abuse this tool might take in the future. If someone decides to throw it at a tree and it's bouncing off of things, all that vibration could certainly pop off a handle scale. So I want it to be belt and braces, and glue it and screw it as well as possibly could be done. I then went around the profile of the entire axe again, just grinding to make sure that the handle scales and the steel end up with a nice perfectly flat surface between both of them. Because I did that, it made the radius on the edges obviously a little bit less than perfect. So I went around again just for one last pass with a nice, I think it was about a 10mm radius bit. Once all those edges were then repolished, I turned my attention to making a Kydex cover for the head. Both pieces of Kydex were heated up using a heat gun. I then put it into my DIY press, which has a couple of pieces of nice resistant but also spongy ether foam inside, and then put the axe between the two pieces of Kydex when they're nice and soft and floppy, and squeeze it down until they go hard. I then create an array of holes with which I can put through the eyelets. I then trim off all the excess on the bandsaw. I keep checking for fit to make sure that it will go in and out easily enough. Again, Kydex sheaths are one of those things that take a lot of fettling. They're a fine line between something just having to fit absolutely perfectly, but the case of getting it in and out is also a challenge, and something you have to account for all the time as you're making each one. I use the heat gun again just to manipulate the edges so that it makes it easier to get in and out. So the two last bits of edge are slightly gaping as opposed to being held tightly together. This just makes it easier to get the axe started when going in. I then take it over to the grinder to clean up all the edges and blend them together. All the edges then have to be sanded up through various grits before they're then polished. And here we have the finished article. If you like my videos and the things I create and would like to see more of it, please hit like, hit subscribe, and then if you also hit the notification bell, you'll be notified as soon as I release new material on YouTube. You can also find me on Instagram, Facebook, or why not check out my website for the most comprehensive information. And if you would like to either order a custom knife for yourself or as a gift for someone, please check out my website, www.brancocustoms.com. Thank you.